welcome to my YouTube channel, Mathematics Made Easy. So in today's video, we want to prove these integral relations. So proof for even f, okay? So assume f is integrable on negative a to a, and then f of x is even, okay? So I want to prove that this is equal to 2 integral from 0 to a of f of x dx. All right. So before we get started, please don't forget to subscribe, like, comment, and also share. Okay, guys, so let's dive into the solution. So what is an even function? So for a function to be even, okay, for a function to be even, f of negative x must be equal to f of x, okay? So for all x all together. So for an even function, f of negative x it must be equal to f of x, okay? Now, for instance, so let's say we have f of x is equal to x raised to the power of 2. Then I want to find f of negative x. So what will be f of negative x? So substitute x to be negative. So we're going to have negative x raised to the power of 2. And that is going to give us x squared. So which is our f of x. So that shows that x squared is an even function. All right, so that's not what we're doing today. So let's prove the integral. Okay, so guys, remember that if you have integral from negative a to a of f of x dx, okay, so this will surely give us integral from negative to 0 f of x dx, okay, then a plus integral from 0 to a f of x dx. Take note of that, it's very important. All right, now the next thing we are going to do now is to deal with this first integral right here. Okay, so dealing with the first integral there, which is integral from negative a to 0, so of f of x dx. Now we're gonna make a substitution. So we'll make a substitution. So we're gonna let x be equal to negative t. Okay, so then if we differentiate, we have the x is equal to negative the t. All right, so if you substitute the limit, when x is 0, t will be 0. When you substitute x to be 0 here, so we have t to be 0. And when x is negative a, negative sign, we cancel a negative sign, then t will be equal to a. All right, then we have the following. So let's move to the next page. So we have the following. So we have integral from negative a to 0 of f of x dx. All right, so this will be equal to integral. So when x is negative a, we have t to be we have t to be a. Then when x is 0, so we have t to be 0. All right, so then we know that x is now negative t, so we have f of negative t, and then our dx is negative dt. Okay, so because of this negative sign, so we can switch the limit. All right, so if we switch the limit, we're going to have integral from 0 to a, then f of negative t, the t. All right, so since f is an even function, so f of negative t will also give us f of t. Then we have integral from 0 to a, then f of t, the t. Okay, so we can change the variable from t to x back. Then we're going to have integral from 0 to a, then f of x dx. All right, so if I substitute this back to this original integral right here, okay, so let's do that and let's check what we're going to have. So we're going to have integral from 0 to a f of x dx, and let me change this back to yellow, then a plus integral from 0 to a f of x dx. All right, I'm talking about this integral right here, the second integral. Okay, so then if you add these two integral together, because they are the same, then this is going to give us integral 2 multiplied by integral from 0 to a of f of x dx, and we have our answer. Therefore, integral from negative a to a of f of x dx. So that's going to give us integral from 0 to a of f of x dx, and that's completed proof. QAD. Alright guys, so if you like this kind of video, please don't forget to subscribe, like, comment, and share. Thanks for watching, and see you next time.